Hey, Chris Matthieu from the Intel RealSense team. In a previous episode, we used Copilot and Gen AI to write object detection code and distance detection on a RealSense D415 camera. So I figured I'd pick up where I left off with that and apply some robotics to the Copilot effort and say, let's write ROS twist commands to follow the person, to move the robot forward if it detects a person and they're greater than a meter away. And when the robot approaches the person, say less than a meter, it should issue ROS twist commands to stop it. So let's just see if we can keep this theme going with Copilot writing RealSense and robotics code. Hey, on a previous episode, we had Copilot write us RealSense logic for detecting a person and displaying the distance away from the camera the person is. So I figured we'd try something a little bit more advanced and practical, like if this was on a robot, say a RealSense camera, depth camera on a robot. So I copied the code we had from the last episode, and we'll start with this, and we'll try to see if we can get the robot to follow us. So by using ROS commands. So I'll show you what a ROS command looks like in JSON, but it's basically a 6DOF command where you've got linear and angular components. The linear is moving the robot forwards or backwards, and the angular is basically using the z-axis to turn the robot left or right. So let's just say something like if you see a person, so it already can recognize a person and it knows the distance. I'll show you the link to watch the other YouTube video. But if you see a person and they are less than 1 meter away, let's say print a ROS2 twist JSON string to the command line for stopping the robot. And I'll say if the person is more than 1 meter away, print ROS2 twist JSON for moving the robot forward, say at 30% velocity, 30% full capacity velocity. Let's just see what this does. I don't actually have ROS installed on this Windows machine, but I am curious if it knows how to print a twist message, which is basically what ROS on a robot interprets to move it. It's thinking. Okay, I see it's adding JSON support. Again, this is from the previous episode, but it's using RealSense 2 as the Python wrapper for the RealSense camera. And again, I'm using a D415 RealSense camera. Okay, we got 36% done. 50%. I love how Copilot and Gen AI it just is not scared at all to just rip out code and write new code on the fly. I love watching it. 80%. So there's your, okay, so let's keep everything, all of its updates. But here's what a twist command, as I was explaining, looks like. When it stopped, all the XYZs on linear and all the XYZ values on angular are 0. So that's stopped. Um, uh, to move the robot forward, you can see we asked it for 30% velocity forward. So there's all zeros on the angular. That's for turning the robot left or right. And then X on a 2D plane is to move the robot forward is positive, and negative to move it backwards. So it looks like it's got that right. Let me save that. We'll come down here and we'll run this rostwist.py. Ooh, first attempt, and it's working. So it sees me there, person and 0.55 meters away. And sure enough, look at the Ross twist commands. Its linear and angular values are all 0. So if I move back a little bit, let's see, let me get back. Yep, I'm over a meter away. Now look, the twist command changed. It's doing uh, zero point 0.3 on the linear x. So it's doing exactly what we wanted. It's amazing. So it's able to spit out Ross twist commands. So essentially, it's moving the robot forward to follow me and stopping when it catches up to me, all written in Copilot, powered by RealSense. Truly amazing. How cool is that? You can buy your RealSense camera at intelrealsense.com and follow along with Copilot and robotics with your camera.